Okay, this is just a real quick one other example that I'm going to add on to this first part of the notes that I'd like for you to take. We're just going to do this next example here. Okay, so it says during a flu vaccine shortage in the United States, it was believed that 45% of vaccine eligible people received the flu vaccine. The results of a survey given to a random sample of 2,350 vaccine eligible people indicated that 978 of the 2,350 people had received the flu vaccine. Okay. Now, this is a legitimate free response question that was on the 2011 AP exam. Okay, so there are multiple parts, but part A was asking the students to construct a 99% confidence interval for the proportion of vaccine eligible people who had received the flu vaccine. Okay, and then it goes on to ask for you to comment whether it's believable that 45% of the vaccine eligible people had received the flu vaccine. Okay, so we're going to start by stating that we are going to estimate P, the true population proportion. Okay, and right here, a lot of times when it says construct a 90 for what? This is what we're talking about, what we're estimating for the true population proportion of vaccine eligible people who had received the flu vaccine. Okay, and we're going to do this at a confidence level of 99%. Okay, so when we increase our confidence level, remember what that does. That increases our margin of error because it's going to make a much wider interval. Okay, our plan. Okay, remember there's a couple things we have to list here. One of those, we have to name the inference method. Okay, so we're going to name the inference method. I like to call it this because this is what it looks like on the calculator if you were to ever use the calculator. It's called a 1 proportion z interval. Okay. Also, part of the planning step is that we list our 3 conditions and we kind of check them off. We need to check these 3 things: random, normal, 10% and normal. Okay, so I'm going to look back through here. Here they mentioned that there was a random sample of 2,350 people. Okay, so that checks that off. Okay, 10%. We're going to say 10 times the number in the sample was 2,350 people. Okay, so we need to say, if we multiply that by 10, does it seem realistic that 23,500 people would be less than or equal to all eligible people for the flu vaccine? Okay, and that's, that is probably realistic. Okay, all right, and then the normal piece. Okay, this is where we take the number in the sample. That's the 2,350. Then we're going to multiply that by our p hat. Okay, by the p hat. Okay, now on this problem, instead of actually giving us what the sample proportion is, you'll notice up here they give us information that we could calculate it. Okay, they tell us that 978 of the 2,350 people were eligible, had received it. Okay, so that makes our p hat 0.42. Okay, that's what we're going to use down here, 0.42. Okay, we multiply those together. We're checking to see, are these going to be greater than or equal to 10? Also, if I take n times 1 minus p, which would be 0.58, that also is definitely a number greater than or equal to 10. Okay, so all of our conditions check out great. Okay, so now we're to the do step. Okay, the do step is where we would want to use that p hat, that's our point estimate. Okay, plus or minus, we need to get a z-score here for a 99% confidence interval. So I'm going to leave a spot there for that. And then after that, we fill in what is the standard error of p hat. Okay, denominator is n, the number in the sample. Numerator is p hat times 1 minus p hat. Okay, that'd be our 0.42 times 0.58. Okay, we're going to calculate what the 99% confidence interval is. Okay, this was 99%, right? Oh yeah, okay. Okay, so we're going to do 0.01 divided by 2. That's one tail there. Okay, that's the area, mean, standard deviation. We end up getting 2.58 if we were to type that in the calculator. Okay. Okay, so 0.42 plus or minus, that ends up being the margin of error, and our actual interval then looks something like this. Okay. Now, if you're tempted to want to try it on the calculator, that's fine. Go ahead and try it if you like on the calculator. Let me also give you this one word of caution. They do not want you on the AP test to do what's called parallel answers, and that's where you go ahead and do it with the formula, and then you also write down some stuff like you've done it on the calculator, because if one of those two ways that you have it written down is wrong, they will always grade the incorrect answer. Okay? When you use the calculator method, remember, you're pressing the stat button, you're going to the tests menu, and you're picking 1 proport z interval. You got to scroll down a little bit until you find it. Okay, 1 proportion z interval. It's going to ask you for 3 things, and when you do the calculator method, you need to write down what those 3 things are that you typed in. Okay, in this case, it would be 978. That would be your x. N would be 2,350, and the confidence level would be 0.99. Should give you exact same confidence interval. Okay, conclusion just looks something like this. We're 99% confident that the interval captures the true proportion of those receiving a flu vaccine of those eligible. Okay, and then we can comment about whether we think 0.45 is plausible or not. You can see it's not in the interval. So we're going to say, since 0.45 is not a plausible value in the interval, it's not believable that 45% of those eligible have received a flu vaccine. Okay, this is going to kind of mark the end of this first part of the videos. I know these were 2 videos here, but I'm going to make one more here so that we can finish up this notes page for these 2 snow days. Okay, great.